Here's a question that was given to students sitting the IB high-level maths exam in 2020. And if you'd like to see anything similar to this on the channel, or if you have any suggestions for any specific problems that you'd like to see, let me know in the comments. So this is an integration question, which looks quite complicated at first glance. And it's the integral from 0 to 1 of x squared over 1 plus x squared, and everything is cubed, multiplied by dx. So although this looks quite intimidating, it becomes easier to solve if we use a certain substitution. Okay, and we're gonna replace x with tan u. And just as a reminder, this is the second substitution method. The first one is when we write u equals something in terms of x, but this is actually the second type of substitution that we're using. So we're gonna replace all the x's with tan u, where u is going to be our new variable. And before we do that, we also have to find what dx is equal to. So we're going to replace this dx by, and this will be du over cosine squared of u. And you can easily see that if you differentiate tan u, okay? And the other thing we have to do is we have to change the integration limits. So in other words, when x is equal to 0, we have tan u is equal to 0. So u is arctan of 0, which is just 0. And when x is 1, then tan u is equal to 1, which means that u is arctan of 1, which is just pi over 4. Okay, so now we can rewrite this integral like this. So this is integral from 0 to pi over 4 of tan squared of u over, and then we just do the same thing in the denominator. So this is 1 plus tan squared of u and then cubed, and then we have du over cosine squared of u, like this. Okay, so let's try to write tan as sine over cosine. So we have integral from 0 to pi over 4 of sine squared of u, and I'll write the cosine squared in a bit, but I'll do the same thing in the denominator. So this is 1 plus, and then we have sine squared u over cosine squared of u, and everything is cubed. And this is du over, and this will be cosine to the power 4 of u, right? Because we took the cosine squared from tan and we combined that with the cosine squared from here, like this. Okay, so now what we're gonna do is in this bracket, we're gonna multiply this 1 by cosine squared u on top and on the bottom. Okay, so this is how our integral is going to look like. So we have integral from 0 to pi over 4 of sine squared u over, and in the bracket we're going to have cosine squared of u plus sine squared of u over cosine squared of u, and everything is cubed. Okay, and then we have the du term, which is du over cosine to the power 4 of u. Now, hopefully we all know at this point that this is actually equal to 1. So the integral then becomes integral from 0 to pi over 4 of sine squared u. Now, I'll bring this on top, and this actually becomes cosine to the power 6 u over cosine to the power 4 u du, right? So I just raised this to the power 3, and I wrote this as the denominator. So now we have another cancellation, which is this cancels out with this, and we end up with a 2 here. So our integral then simplifies to this. So integral from 0 to pi over 4, and it will be sine squared of u times cosine squared of u, but I'll write this as sine u cos u squared times du. And now we're going to use some trigonometric identities. The first one that we're going to use is the fact that sine of 2u is equal to 2 sine u cosine u. Or if we rearrange this, we can get that sine u cosine u is equal to sine of 2u what divided by 2. Okay, and we're going to substitute that in here. So our integral will become this. So integral from 0 to pi over 4 of, and if we square this, we're going to get 1 over 4 sine squared of 2u du. Okay, so we're not done yet. We still have one more thing to do, which is we will apply the double angle formula. Okay, so I'm going to take out the 1 over 4 in front of the integral, and this is going to be this. And sine squared of 2u is going to be 1 minus cosine of 4u over 2 du. Okay, so this becomes 1 over 8 if we combine the 1 over 4 and the 1 over 2, and this is integral of 1 minus cosine 4u du. Okay, and we're almost done. Now this is one of those direct integrals that you can solve using any integration table that you can find. So this will be 1 over 8. Now first we integrate the 1, which will just be u from 0 to pi over 4. And then we integrate cosine of 4u, which is sine of 4u over 4 from 0 to pi over 4. Okay, so finally our integral becomes 1 over 8 multiplied by, now this is just going to be pi over 4, and then we're going to subtract 1 over 4, and now we're going to substitute u first as pi over 4 and then as 0. So this is going to be sine, let's put some brackets here, so sine of 4 times pi over 4 is just sine of pi, minus sine of 0. Okay, so we know that this is 0, we know that this is 0, so this whole thing just cancels out, so this is 0, which ultimately gives us that the integral that we started with is equal to pi over 32. And that's the end of the question.